Hello everyone, my name is Shivam and welcome to my YouTube channel. In this video, we're going to discuss about HashMap. Okay, so if you're watching this series from the start, you might be having the question that why I'm starting the HashMap. Okay, so in the previous sessions, I have completed the list implementing classes, and just after completing the list implementing classes, I'm starting the HashMap, that is map implementing classes. So why I'm not starting the set implementing classes? So the reason is because the most of the classes in our set implementing classes, which is hash set, linked hash set, or tree set. So all these classes are internally using the map implementing classes. Like hash set is using the hash map, the linked hash set is using the linked hash map, and tree set is using the tree map. So that's why if you want to understand how the working of set implementing classes is happening, for that we need to understand how the map implementing classes are working. Okay, so for that I'm starting with hash map. Okay, so now starting with the basic introduction of a hash map. Hash map is introduced in our Java in Java 1.2. So this hash map is a map interface implementing class. Okay, so directly or indirectly this class is implementing our map interface. Okay, so we can directly say that this hash map is a map hierarchy class. Okay, so with a hash map we can store the object. Okay, if we can store the object as a key and value pair. We can store the object as a key and value pair. Okay, so we call this key and value pair also as an entry. Okay, the combination of key and value pair is called as entry. Okay, so this was a short introduction of hash map. So why basically was this hash map is introduced in our Java 1.2? Okay, so we were already having this hash table when we already have hash table. Okay, so the functionality of hash map is almost as same as that of the hash table. That means hash table was storing the entries, that is key and value pair, and likewise the hash map is also storing your key and value pair. Both of them are not maintaining any insertion order. Okay, and both of them are using the same data structure to store the elements. So what was the reason that your hash map was introduced in Java 1.2? So the main reason was because of the synchronicity. Okay, so this hash map, okay, hash table, let me just, hash table is a synchronized class. Okay, synchronized class. Against this, our hash table, okay, hash map is a non-synchronized class. So what is happening is that whenever you are working in a multi-thread environment and your operation is not to modify your hash, okay, hash map or hash table, so in that condition the having the synchronization will going to reduce your performance when multiple threads are acting just to store your element or to search element. Okay, so this operation, that is adding operation and searching operation, I'm not talking about the modifications here, but yeah. So whenever these operations are performing, the hash table was giving us in poor performance because it was a synchronized class and it was locking your methods for every execution of its method. Okay, and to solve this issue we are come up with the new class in Java 1.2, which is a hash table class. One more thing was that, okay, you're going to understand this concept very easily when I'm going to introduce or explain how the internal data structure works. Okay, so the thing is that uh, the time complexity. Okay, so time complexity of get method or remove method or contains method. Okay, so these are some of the methods. So for this, time complexity is 0 to 1 in ideal cases. Okay, but if but suppose your hash algorithm, okay, hashing algorithm, which is used to store your entries inside your hash map. So this algorithm is consider this algorithm is written poorly. And in case of the hash table, what is happening is that because of this hashing algorithm is written poorly, all maximum of the entries are stored in a same bucket. So whenever this multiple hash collision is happening, that is the entries is having the same hash code because of the hashing algorithm, and since this multiple entries will going to store in a same bucket. Okay, so same bucket. So because of this time complexity for get method, remove method, or contains method, it is increasing from 0 to 1 to the 0 to n. Okay, so this, because of this, it is giving us a lot of poor performance. And to solve this issue in Java 8, HashMap was uh, also using. Okay, let me just complete this statement. But hashing algorithm, but if your hashing algorithm is written poorly, okay, so if your hashing algorithm is written poorly, time complexity becomes 0 to n. Okay, so to solve this issue, okay, so this issue is still available in the hash table. But to solve this issue, uh, in Java 8, in Java 8, hash map, okay, so hash map, I'm talking about the hash map, is given with one solution. Okay, and that solution is that whenever the elements, okay, elements inside the one bucket, inside the one bucket of your hash map goes beyond the 8. Okay, so in that condition, if your elements are storing in a single bucket of your hash map, so that if that number is going beyond 8, so in that condition, the internal algorithm to store this element is changed from, okay, so storing of these elements is changing from bucket. Okay, so this bucket is also called, we can also call this a single linked list. Okay, so this is internally a single linked list. We call this single linked list as a bucket. Okay, single list, single linked list to balance tree. Okay, so because of this conversion of single linked list to the balance tree, our time complexity is again reducing to 0 to 1. Okay, so this is how the hash map is solving the issue of the time complexity. Now coming to the main discussion, which is the internal data structure. So what exactly is that internal data structure is implemented by hash table? Okay, so it is internally using the hash table data structure, so which is a bucket data structure, same as the hash table data structure. Okay, which internally uses bucket data structure. Okay, bucket data structure is nothing but a single linked list. Okay, so initial capacity, what is the initial capacity of hash table? Okay, hash table, I'm talking about the initial capacity, which is 16. Okay, we will also going to see the actual if it is 16 or not in the programming section. So what is the increment capacity? It means, okay, load factor. First, load factor, that means of how much element it needs to fill. After that, the capacity is going to increase. Like for this hash map, it's in 0.75. That is the 75%. 75%. So 75% of 16 will going to be like 12. So whenever the 12 entries are going to store inside your hash map, its capacity is going to increase. So how much capacity is going to increment is increment capacity. Increment capacity will be like double. Okay, so double. It means if your capacity is like 16, so next capacity will be like 2 exponential. So this 16 will be like 2 raised to the power of 4. Okay, so next capacity will be like 2 raised to the power of 5. Like this, the capacity will going to be incremented. Okay, so now let me share with you one document. Okay, so this document is prepared by me for you to show you the better representation of hash map. Okay, so let me open my document, searching my document. Okay, so here you can see this document. Okay, the same points are mentioned here which I have just told you just before. That is, hash map is a map interface implementing class which stores the object as a key and value pair. Okay, so this second point which I have discussed in the hash table also, that it cannot store the duplicates key. So whenever you try to store the key and value pair with a key which is duplicated, so in that condition what is happening is that the the value associated with this key, okay, which we are trying to duplicate, so this key will going to be same, but the value is going to be overridden with from the previous value to the next value. Okay, now this class, if you want to understand this thing betterly, you can watch my previous video where I explained this thing in the hash table. Okay, so now this this class does not make any guarantee to the order of the entry. So okay, so it is possible that you are going to get an insertion order, but there is no guarantee that it is going to maintain the same order, okay, throughout the procedures. Okay, now coming to the data structure, it internally uses the data as table data structure, and which again internally uses the bucket data structures. Okay, so this is not a synchronized class, allows the null insertion only one time as a key and can be inserted multiple times as a value. Okay, so if you want to assign your key as a null, so we can do it for the one time, but as the key value cannot be duplicated, so we can only apply or use this null as a key for one time only. But as a value, you can use null as many times as you want, unless and until your key is not duplicating. Okay, so the initial capacity of hash map is 16, which I have already discussed. A load factor is 0.75, is 75% of 75%. Okay, so when number of entries in the hash table exceed the product of the load factor and the current capacity, the hash table is rehashed. Okay, so this is an algorithm of how you can store your nodes or key and value entries inside your hash table. So we're going to discuss about this data structure. So we're going to understand about these things very deeply. In the next video, I'm going to explain this thing very clearly in detail. Okay. So now coming to this next thing, which is iterator written by all this class. This is collection view method or fail fast iterator. So in the fail fast iterator, so whenever you do any modification after the iterator object is created, and when you are iterating the object, and if you do any modification to your collection object, so it is going to throw the concurrent modification exception. Okay, so this is how your capacity is incremented when you have reached your load factor. So initial capacity is 2 raised to the power 4, which is 16. So next capacity incremented will be like 2 raised to the power 5, which is 32. Like this, your capacity will be incremented for each load factor reaching like 2 raised to the power 6, 2 raised to the power 7. Like this, the capacity will be incremented. Okay, now coming to the programming section. We are coming to the programming section. Okay, in the programming section, first thing we need to understand is the constructor. So in HashMap, we are having the 4 constructors. Okay, so first constructor is a zero param constructor, as we have already seen. So in whenever we create an HashMap object with this constructor, the HashMap object is created with its default capacity 16 and the default load factor 0.75. The next constructor is in constructor where we can pass the initial capacity. Okay, so in this condition, load factor will be same as that of the previous case, that is 0.75, but the initial capacity is the one which we have specified. Now coming to the third constructor. Okay, so in this constructor where you can pass the initial capacity as well as your own custom or your own load factor. Okay, so the load factor is in the fractions mode. Okay, so you can only pass the load factor in the range of 0 to 1. Okay, so like 0.75 represent the 75%. Like this, you can pass your own load factor and also the initial capacity. And lastly is your hash map constructor where you can pass the other map implementing classes. Okay, so it is going to copy the entries inside your map, okay, which you are passing to the constructor and create your new hash map object. So to understand things betterly, let us get to the programming section, okay, where you can understand things betterly. Okay, so okay, so let me create an hash map object. Okay, hash, okay, object is, okay, it is taking some time, no worries. Okay, hash map. Okay, so here you need to pass the generics. So which type of one key you want to provide? So I want to provide the key as in string type. So here is the one thing which I have already told you in the hash table, that it is recommended to take your key. Okay, so the object type should be must be or should be, okay, it is recommended only. So the type must be the one which is immutable type. So string here is an immutable, that's why I'm taking string as a key. Okay, now value will be type any type, so I'm taking object. So hash map equals to new hash map. Okay, same generics is used. Okay, now, okay, so let me show you what are the other constructors also available for better understanding. Hash map. Okay, so here you can see the constructors available. Okay, so this constructor is for the zero parameter. This constructor is where you can pass your initial capacity. This constructor is where you can pass your initial capacity as well as your load factor, and this last one is for this constructor is the one where you can pass the other map implementing classes. Okay, so this was about the 4 constructor available inside your hash map. Now coming to the actual programming part, I'm creating my HashMap object with a zero param constructor. Okay, so let me also show you its initial capacity and all this thing. So as this is in Java 1.2 class, so capacity method is also not available here. As you can see here, let me just show you capacity. So there is no capacity method available. So if you want to see the capacity, let me just go to that class. Okay, the predefined class implementation provided by the Oracle Corporation. So I came to this predefined class. So here you can find, okay, so here you can find this one sentence about this, just about this constructor definition. Okay, so construct an empty hash map. Okay, so with a default initial capacity. So what is the default initial capacity is 16. Okay, so here you can see that it is creating your hash map with the default initial capacity 16 and the default load factor 0.75. Okay, so this is how your HashMap object is created with the uh, zero param constructor with its initial capacity and load factor. Okay, now coming to this part. Now coming to our first operation, which is add operation. Okay, so there is no add operation in this hash map. So if you want to add the object or add the object and or we can say the key and value entry inside your hash map, for that we are having the put operation. So hm dot put. Okay, so with this we can insert the entries inside your hash map. So here you can see the put method. Okay, so we are having the different forms of the put method, so I'm going to use this form. So in this form here I need to pass the key and value pair. Okay, now key and value. So the key should be of the string type. So here I'm taking some random key and value. So I want to pass value as in one integer value. Okay, like this I'm creating the other objects b, 2, 3 and c. So this is how you can insert the key and value pair inside your hash map. Okay, so let me just print this for you to show that hm. Okay, so here you can see the key and value pair inserted inside this hash map. So let me also show you that it is not accepting the e accepting the key duplicate. Okay, so not this compute method. Here I'm passing the key as a b, which is already present, and value as like something 6. Okay, so this pair is already this pair where your key is already present is already available, like this one, but the value here is 2 and the new value I'm assigning is 6. So in this condition, this 2 value will be overridden with this 6 value. So let us see if it is happening or not. So as you can see that p value is already overridden. Okay, so here you can also see that this index of this last entry should be last one, but so as there is no guarantee that it is going to preserve your insertion order. Okay, so this is also one thing you need to remember. Now let me also show you the insertion the null as in key. I'm putting it here null, so like it is I'm providing 4. Okay, so null you can also pass as in key. So from this example, you can also observe that it is not maintaining any insertion order. Like this, you can again try to like I'm providing here e, and you can also provide value as a null. Okay, let us see that yes, it is doing that. Okay, so this was about the add operation. Now let us see also one more operation, which is size, if there is available or not. Okay, size is available, so here you can see how many elements are present inside your hash map. So let me change the console position. Yes, okay. Now so we are done with the size and the add up putting operation. So now we can see the remove operation. Okay, so for this I'm using the hm dot remove method if available. Okay, so we are available with the remove method. So let us see this remove method. We are available with the two overloaded forms of the remove method. Okay, so in the first form you can remove the object by passing its key. As the key is unique, you can remove that entry. And second one is unique, you can pass your entry which you want to remove, that is key and value pair. Okay, so this one, so I'm going to use the first one, which is where I can pass the key. Here I want to remove like c, I want to remove. the entry which has the key as a C. Okay, so I'm going to again print this hash map. Okay, now let us see. Okay, here you can see that C is not available, but in the previous case C is available, C entry is available. Entry where your key is C available, but in the latest hash map printing there is no entry available where your key is C. Okay, so like this you can perform the remove operation, the other remove overloaded forms also. Okay, I'm not going to get into that much, but yeah, now coming to the get operation. If you want to retrieve a certain object value from your hash map, so in that condition you can use the this get method. Okay, so hm.get. So here we're going to find the different forms of hash map okay, just back. Okay, so here we're going to find the different forms of the get method. So this one is what of our interest. Okay, so here you need to pass the key. Okay, of okay, so by passing this key you can retrieve the object related to that key. Okay, now let us just try this get. Here I want to retrieve the object or value which is represented by a. Okay, a. Let us see if it is performing or not. So it is giving me the 1. So here you can see that the value related to your a key is 1. Okay, so it is performing that. Now coming to the second of the last operation we're going to see in this operations, which is contains operation. Okay, so I'm printing it. Okay, so problems are here. Just rectify this problem, and then again s out, then hm dot. Okay, so here I want to check if that key value pair is available or not. So there are two methods available for us to check if that certain key is available or not, or that certain value is available or not. Okay, so we have these two methods, key contains key and the contains value. Okay, let us see both of these methods one by one. It contains key, so I want to check if C is available or not. Okay, and here I want to check contains value method. Okay, so in this case I want to see if my like 6 integer is available or not. So let us see if it is performing the operation or not. So here you can see for the first operation, which is hm dot contains key, C is not available. Why? Because we have removed our C as a key entry. Okay, so that's why whenever we call the contains key for the key, it is giving us the false result. Okay, and for the sixth value, that is if your hash map contains the entry which has a 6 value. Okay, so for this we are already available with this entry with a key as a b and a value as a 6. Okay, so that's why it is returning us an true value. Okay, so these are some of the simple operations of simple operation of hash map. Okay, now going back to the that diagram which we have just discussed. Okay, then let me just change the positions. Yeah, so okay, now okay, we have seen up to this point, that is various constructor available. Let me show you one more thing. Okay, so and that thing is creating your hash map object with the the spec by passing the other map object. Okay, let me show you also that. Okay, so here I'm creating. Okay, then so here I'm creating hash map. Okay, hash map with a string. as a key and object as a value. Okay, so I'm taking the variable name as hm2 and creating your new HashMap object. Okay, so in this condition, I'm going to select an HashMap object where I can pass my map implementing classes. So my first implementing classes I'm passing is the one which I've created earlier, that is this object. This object I'm going to pass to this new HashMap object creation procedure. Okay, so I'm passing it as an argument. Okay, let us see if it is creating an HashMap object or not with the given HashMap object. Okay, let us see. I'm executing it. So lastly, here you can see that this object is created by using the this values. Okay, so the all the element, the entries which is already available inside my previous hash map. So it is copying that entries to your new hash map and creating your new hash map object. So this was about the the hash map operations. Okay, now coming to this part, what remains is this diagram. So this diagram is just an overview of how your entries are stored inside your hash map. Okay, so these each of the rows represent one bucket. So one bucket is nothing but the single linked list. So here you can see this. Okay, so okay, so here you can see this. This is nothing but a one bucket, and one bucket is nothing but your one row in this hash map. So there are totally 16 rows. Okay, so 16 places available, and each row represent the single bucket. So inside the one bucket we can store the uh, many entries. Okay, so each entry is stored as a node which contain the three values, which is one. Okay, two of them are key and value, and third one is then address of your next node. Okay, so this next node. Okay, like this next node is also contains the three value, which is key and value pair, and also the next node address. So this is how your single linked list works, and this single linked list is nothing but the bucket. Okay, so we are also having the bucket data structure, which I'm going to explain in the next video for you to understand how the storing procedure is works happening betterly. Okay, so this is nothing but the array of buckets. Okay, so now coming to the advantage part. Okay, so what is the advantage of a hash map? So advantage is it's implementing the fail fast iterator. So this fail fast iterator is very good when you are performing the storing operations or iterating operations. Okay, so we're going to see about how this fail fast iterator works in detail in the cursor sections. And now coming to the second is faster access to the element due to its hashing methodology. Okay, so as this each and every element is stored inside the bucket, which is each bucket is having a specified or unique hash code. So because of this, the access to this element is quite faster. Okay, now coming to the third one is allows the insertion of the key and value pair. So this advantage I'm talking regarding the conditions where we can only store your object without having any identity. So it means I'm talking about the collection hierarchy classes like the list implementing classes, set implementing classes, and the queue implementing classes. Now coming to the disadvantage part. Okay, so what are the limitations of your hash implementing classes? Occasionally, hash map requires the resizing when the original size of the hash map bucket are full. Resizing takes 0 to n times as the element from the previous hash table hash map are transferred to the new bigger hash map. Okay, so whenever your capacity is increased, so you need to change the location of these buckets because these buckets are assigned because of their hash map. Okay, hash map. Okay, so hash values, and we need to reassign this buckets whenever your size is increased. So this is quite like a time consuming procedure, because of which it is reducing your performance. Now coming to the last part, which is when to use your hash map. So hash map is used when you want to store your object with its identity means as a key and value pair. Okay, without any requirement for storing them, okay, without having any requirement for storing them in any order. So you no need to, in a case where you no need to worry about its order, the entry is storing by order. So in that condition you can use the hash map. Okay, so when searching is more and based on the key, so this is also the condition. So most of the time when you want to just store your key and value pair, so in that condition we mostly go for this hash map. So in the practical user, this hash map is most of the time used. So this is all about the hash map. Okay, so you can download this document from the description section. Okay, so where I'm providing the GitHub link where my document will be available, so you can download this document from there. Okay, so this is all about the hash map, which is a map implementing classes. Okay, so in the next video we're going to see how the internal data structure of the hash map works. Okay, so thank you for watching this video.